Hi everyone. Today we are going to discuss on relay coordination for motor protection in ETAP. Okay. So motor is a major load in industries. Today in ETAP we are going to simulate an network with an load, electric motor loads, and we are going to apply the relay coordination setups and how it should operate a relay during the fault conditions. We will go into the ETAP environment. As you see, the ETAP environment has an file. I have created a new file, new project here, and this is a new project which has been created. Here we have a lot of instruments, DC elements, and other elements available in this window over here. Here in the left side you can see system manager, so where the file is located, the project file, this single line diagramic view, and it is a star system, star Z system for relay coordination, all other things it is available. In the top you can see this is for power load flow analysis, this is for short circuit study run, this is for arc flash, and for DC arc flash, and everything is available over here. You can choose an appropriate, where this is an edit option. Whenever you create a project, so if you want to edit that project, make some changes, then you should go to this edit option, then you can make the changes. You want to run it for load flow, you can go to this tab, the system will can be executed for power flow. So I am coming back to edit. This is a new window. So here this is a drag and drop system, so it is very easy for you. And see grid, I am taking a system from the grid. So this is an you can see the name power grid, so I just made an power grid. This is 0 MVA SC short circuit, so we need to set what is the fault level MVA, or we call it as an short circuit MVA, okay, because based on this only the fault current will flow into the system. So double clicking on this, it will give you this window, and I'm just ensuring whether yeah, this window is not available for you right now. Just a second, I will make you to see this also. I think it is visible for you over here. Yes, I think it is visible for you right now. So this is an edit window. So power grid editor, where you can name this as your wish. This info is for general, what are the things you have set. It is shown here. It is in 3-phase. You can add a tag to this. You can name it, give some description about this. Info is about what kind of ID you can give everything, and what is the kilovolt of this swing bus or a grid. So in the ratings, if you go, you can set this rated. So I am taking, it is an 230 kV grid system, okay, and I need to set short circuit MVA short circuit for a 3-phase system. I am taking 230 MVA or 300 MVA may it be. So if you know the short circuit fault level of a particular system, you can give it over here, because it is very important. So it is 230 MVA short circuit now here. So once grid is available, I am going to transfer power through a transmission line or through cable. So to the system I am taking a transmission line, okay. So before this I can go with an definitely the system will be with the protection at the both the end, from the source and also at the load end. So I am going with an I'm taking an CT over here. So you can see a CT is connected, and if there isn't CT, sorry, before the CT I should also give you, before the CT I should give you an circuit breaker to open this, right? So I will go with the circuit breaker, I will go with the high voltage circuit breaker. Now there is an high voltage circuit breaker available there, and this is in bus. So beneath that I will keep my CT, and from the CT the input has to be given to the relay. I am taking a general purpose relay. You have a lot of relays over here. It is a multifunctional relay. This is a motor relay, overcurrent relay, solid strip trip relay, solid state frequency relay, voltage relay, reverse power relay. A lot of relays have specific ANSI codes, and I am taking in multifunctional relay. Okay, so I have a CT, I have a relay and a circuit breaker. Then I can connect a transmission line. Beyond that point I have a transmission line, and this, see, I am moving the transmission line, but this point is not moving, but this is a point of coupling point, which is, we call it as node or a bus. Okay, so it is in bus. So if I take that bus, it can be okay. Then again at the end of this transmission line, again I need an protection, right? So I should have a protection to safeguard my system. So I should have an CT, then I should have an circuit breaker, and the CT has to be fed into the relay, and relay has to open this circuit breaker. So now this transmission line transfers power from the grid to a system. Then system should have a bus, receiving bus. Okay, so now this is given to us bus. See, when I connect the bus, it automatically takes the voltage 230 kV, because I have given this grid as 230 kV. Okay, or if I don't need bus also, I can directly give it to the transformer, but here I am giving a bus, and then I am taking in a transformer. So I am connecting a transformer over here, or else I can even remove this bus also. I can directly give to the transformer. That's all. Then connection point will have definitely a bus. Okay, now transformer point has a protection. Okay. So now the transformer has to be given with all the parameters. So what rating of a MVA? This can be of 3 MVA transformer. It can be okay, and its impedance, 3 MVA transformer impedance about 5.6% impedance. You can see the nameplate details to get all these details of a particular transformer, and its primary and secondary. Primary, it is taken to 30 kV. Secondary, I am taking it as an 0.415 kV, which means 415 volts. Okay, so now it is set, it is an 230 bar 415. Okay, 3 MVA transformer. Now again from the transformer I need to feed to and feeders. If multiple feeders are there, then I should take a bus. Okay, now if I connect the bus, it will take 415 volt. Before that, to ensure my protection, I am again giving circuit breaker with relay systems and everything for the protection of this transformer. I should have a relay which is a low voltage relay. I should have a low voltage circuit breaker for 415 volt, and then should be given with circuit breaker. One second. CT, and it's another relay. This is on the bus primary side. It has taken 415 kV, okay, and if I want to stretch the length of the bus, it is easy. You see the color differences. Why? Because another important thing in the transformer is grounding. One second, I think these tabs are visible. Yes, the tabs are visible, right? The grounding, can you able to see the grounding? Yeah, grounding, it's visible. Yeah, you can see we will use TNS system for earthing type. The primary side is delta and the secondary side is solidly grounded, star grounded, okay. So that's why this is a grounded side, so the color coding is different. So you can able to see here the earthing, grounding, based on these grounding types. It is okay. So delta side and this star grounded side, the color changes here. So I am taking and two motor loads, induction motors. Okay, two motors. So these two motors are running under this transformer. Okay, two induction motors I have taken. I can give all its nameplate details over here. Even I can choose a specific type of motors, 415 kV motor, and design at how many HP or kilowatt it can be. I can take it each into 200 kilowatt motor. Okay. And I am taking one more meter, nameplate details, going into library, or else I can even also type what is the kilowatt I want to keep. If it is a 1 MVA, it's a 1000 kilowatt is a 1 MVA. Okay, and its voltage 415. So it will take all other things as an defaulted things. It will assign itself. So you can also choose a specific parameter. It has given you a lot of options over here. And here this motor protection I need to, if I have a cable in connecting these things, then I can have on both sides a second. If I can have a cables over here. I can take cables. If I am connecting these motors through cables, even cable side also can fault happen, right? I will have these relays to trip a specific faulted motors. and I need a relays to trip all these things. So now relay. Same with setups. I can have an CTs over here. I can have this CT also over here. I can have a relay over this point. And I should have a relay to operate these also. So how many layers of protection we should have in a system? So if you are operating these two loads, and if I am having an cables, and fault can happen inside this cable or this point, so this relay should not trip. The upstream relay should trip towards the source, because the fault will go towards the load and power will flow from the source to the load. Okay, so we should protect it. So if this is a case, a cable is in system, so we are responsible in protecting the system separately. So if fault happens in the motor, cable should not get damaged, so I will cut off the fault over here. If a fault happens at the motor cable, my bus or other system should not get damaged, so I will cut off over here. If a fault happens at my bus, my transformer should not be getting faulted, so the trip happens over here. If beyond in the transformer the fault happens, this circuit breaker will open. If in this transmission line it happens, this will open. So we have a lot of systems. These are looking very simple, but this is a complex systems integrated. So we have protection at these stages, and here comes we have to set up these relays. So in a relay, I think the module is visible to you. Yeah, relay, we can click what is the input. CT15 is an input for this relay. You just verify just CT15. Can you able to see the CT15 is going to be the okay. What is the circuit breaker name? It is 10, and this relay output should be set to relay element. HV circuit breaker, CB5 and CB6 is there. LV circuit breaker, CB7, CB10. So the output, it is DO1. You can choose for phase, neutral, ground, negative sequence, whatever the relay element. I am taking any. So level, you can OC1, OC2 or curves. I will show you in this OCR. So I am taking any. On any OC it comes, please give the output. Okay, the output is now DO1. So I have to choose to which we have a high voltage circuit breaker, low voltage contactor, SPST, everything. So I go with LVCB, low voltage circuit breaker. So low voltage circuit breaker. So CB10, we have a lot of low voltage circuit breaker. I am going with CB10. Then what is the action I should take, either to close or open? I am given it is in close during operation. So if a fault is detected, it should open. So I am choosing open. Okay. Then going into OC1, I am enabling here. Here also library is there. Now I need to choose what type of relay you are going to use. I am using ABB, Allen Bradley, whatever you have, L&T, Omron. So I am taking ABB. And what is the model you specifying? I am taking with REF, it is in feeder protection, REX general protection, RET for transformer protection. So I am taking REF 615, it's an overcurrent protection. Okay, now you can see REF has OC1, OC2, OC3, 5 curves. I am taking OC1, and OC2 it is already disabled, so I am just enabled OC1 curve. So what kind of curve type you should use? Usually we will use IEC, normal inverse. IEC normal inverse I am using. So what is this CT ratio? We should also fix the CT ratios. So these CT ratios we will, based on its full load current, we will choose the CT ratio, and the pickup value is from the CT ratios. Okay, so here I am just going into the CTs initially to show to you. So if you go into the CT, here we will have a what is the primary, what is the secondary. So to know that if this is a 1 megawatt load, so at 415 what will be its full load current. For a 3-phase system, for example, I am just going, if it is in 350 amps, okay, so if 350 bar 1 amps or 350 bar 5 amps, I can go with this CT ratio and its turns ratio. I am going 350 bar 1. Okay, so what is its burden? It's 1.75, 2.5 VAs can be the burden. So now I am setting that. Based on this, now CT ratio, at what should be the pickup current. Okay, so pickup can be of, I am taking primary current. If it is 0.05, it is 17.5 amps, but I am saying if 100 amps comes, it should pick up. So 100 amps can be 0.28, 29, 288, 287, 287, okay, 267, 259, 58, yeah. 0.2858 is 100 amps. If 100 amps comes, it has to pick up the overcurrent. Time dial, it is a time multiplier setting based on its IEC inverse curve. Time dial, you should choose 0.1. So we have a separate calculation for this time dial. I will show you in the next video. This is an instantaneous, so a 3-phase fault current. If my short circuit fault current at this point, based on is MVA what we selected, is you think about some 2000 amperes. So if 1000 amperes comes over here, then it should trip. So 1000 amperes, 3500 amperes, 1750 amperes. So 1050 amperes comes, immediately it should trip. Okay, so I just taken it, and the time delay is 0.01. Minimum it should start from 0.01. Okay, so I taken the minimum time period, or you can go with 0.03 seconds, that is 30 milliseconds. It is taken. I am setting it. Now if a fault happens over this point, and this relay will operate in this manner, so I should set this relay systems less than that, and this relay system more than that. Likewise, I need to set these parallelly operating based on its current value, the timing, everything. So for so this is a system. You can run the power flow. Just click on this. I'm taking test. It has cable length, because I have not set all these, because a lot of parameter has to be set, so these are not available as of now. Impedances, cable lengths, and all things has to be given. So this is a setup creation, and we need to set all this length of the cable, length of the transmission line, impedances, and I need to set all the relays and everything. So I have a system that has been created earlier. I just opening my earlier project to show you that. And here I will show you the relay coordination of my previous work, which is a larger network. I'm just zooming it out. I think it's not much legibly visible, but even though you can see the size of the network. Okay, so I'm zooming in. I have entered all the things from the grid. It is a 600 MA short circuit system with the transformers, and it is in a real system, and what are their protections I have. Everything is given over here. I have set all the cables and its length 440 meters, what are the cable type, and everything I have set. What is this relay, what is this circuit breaker is about, the CT ratios, everything 450/1, and this relay output, it should open circuit breaker 5, and what is OCR, L1, OC2, this is disabled, and what is the phase instantaneous pickup values, and neutral, grounding, negative sequence, everything I will set here in everything. So I am going to show you two things. This is an ungrounded system. This is an grounded system with a lot of transformers. We have more than 20 transformers over here. I am going into now show you short circuit relay coordination over here. I am going to introduce a fault. Is a single phase ground fault. I can even go with a 3-phase fault also. I am going with a 3-phase fault. So I am going to create a 3-phase fault over the secondary of the transformer. It will execute, and what are the fault currents, what are the voltages, and everything. You can see 32 kiloamps of fault current flows in the primary side. You can see on the primary side of transformer the relay started to open. So for this fault, so you can see the sequence of operation. The relay 45, 26, 24, 23 has operated, okay, for this time instance here. So same kind, I am just making an 3-phase faults now in the above bus of the transformer somewhere. You can see which relays are coordinating. Now you can see on the HT side it is 5.4 kiloamps. Here it is something about more than 30 kiloamps in the LT side, but on the HT side you can see 5 kiloamps, and you can see the relay coordination over here. It is not disturbing any other parallel feeders, and this is an HT side fault. So what happened, I have given up to 10 relays to open, so it is showing you all the coordinated relays how it is getting opened over here from the relay 28, 27, 24, 23, 8, 5, 4, 2, 1, at what time periods it has been opening, at what current levels it has been opening, it is shown. So by this way you can coordinate your system and protect for a particular system. You can see the parallel feeders, but it is not disturbing these two things, okay. Even I can show you one more example. These are multiple parallel feeders from a particular buses. I am just giving an fault over this point. You can see the fault is clear initially at this stage, then if it is not, then it goes to this point, then this point, and this, and it goes to top. It will not disturb any parallel feeders. So this is a wonderful thing in relay coordination. You need to choose timing, time multiplier settings, and everything. So it is one of an important part in protection in our electrical system. Thank you. Keep watching. We will update you with next updates.